All right. Dobro jutro, kolege. Good morning, everybody. Let's get started with this fifth workshop of the Serbia Irrigation Strategy. Thank you very much to all that registered and joined. I'm very happy to welcome you here all. And without further delay, I will leave the floor to the Water Management Directorate, to the Director Natasha Milic for her welcoming words. Over to you, Natasha. Thank you.
Thank you very much, Jacopo. Zahvaljujem se, Jacopo, i pre svega želim da vas pozdravim ispred Ministarstva poljoprivrede, šumarstva i vodoprivrede Republičke direkcije za vode. Republika Srbija i Evropska banka za obnovu i razvoj potpisali su 20. decembra 2019. godine ugovor o zajmu za investicije u oblasti navodnjavanja ili kako ga zovemo program za otpornost na klimatske promene i navodnjavanje u Srbiji, prva faza. Pored izgradnje i rehabilitacije infrastrukture za navodnjavanje, Evropska banka za obnovu i razvoj u saradnji sa FAO, Organizacijom za hranu i poljoprivredu Ujedinjenih nacija, sredstvima bespovratne pomoći finansira izradu strategije za navodnjavanje sa 5-godišnjim akcionim planom. Izradom ovog strateškog dokumenta definisaće se budući pravci razvoja navodnjavanja zajedno sa svim ključnim akterima u ovoj oblasti. Iskoristila bih još jednom priliku da se zahvalim EBRD-u koji je prepoznao važnost i potrebu izrade ovako važnog strateškog planskog dokumenta i naravno FAO organizaciji koja je uključena sa svojim ekspertima na izradi ovih dokumenata zajedno sa svim relevantnim institucijama u Republici Srbiji. Kako smo svi mi poslednjih nekoliko decenija svedoci pojave i posledica izrazitih klimatskih promena koje se dešavaju širom zemaljske kugle, možemo reći da je u Republici Srbiji, što se tiče ovih klimatskih promena, najugroženiji sektor poljoprivrede i naravno voda, odnosno vodoprivrede. U skladu sa tim, danas ćemo imati prilike da na radionici koja je upriličena za danas, pod naslovom Uticaj klimatskih promena na poljoprivredu i vodne resurse u Republici Srbiji, da od strane eksperata FAO-a u obliku prezentacija dobijemo podatke, odnosno čujemo sve trendove koji su se dešavali u okviru klimatskih promena, kao i buduće projekcije šta nas u budućnosti vezano za ovu temu čeka. Dakle, zaista jedna zanimljiva tema, puna korisnih podataka koje ćemo imati danas prilike da čujemo. Meni na kraju ostaje da sve učesnike danas pozovem da aktivno učestvuju i da u delu koji je odvojen za pitanja komentarišu i učestvuju u ovoj radionici i naravno da svima poželim uspešan rad. Još jednom hvala i pozdrav iz Ministarstva poljoprivrede za sve današnje učesnike.
Many thanks, Director, and thank you for the nice words. It's always a pleasure. Let me now give the floor to Tankut Erkan, who's from the European Bank for Reconstruction and Development. Please, Tankut, the floor is yours. Over.
Thank you very much, Jacopo. Good morning and a warm welcome to all our guests. We are delighted to have you with us in our workshop on climate change and its impacts on the agriculture and water sectors in Serbia. EBRD is committed to improving the agricultural production and strengthening the sector's resilience to extreme climate events and improving water efficiency and environmental sustainability. In this regard, EBRD is financing the critical irrigation infrastructure investments to enable the rehabilitation and modernization of the irrigation system in Serbia. In addition, in cooperation with FAO and the government of Serbia, EBRD is supporting the development of the National Irrigation Strategy and the action plan. I hope you will enjoy today's workshop. I believe it's a very exciting topic. Again, a very warm welcome to all of you. Thank you for coming.
Thank you very much, Tankut. And again, thanks to both the Water Management Directorate and the EBRD for the opportunity of engaging in supporting Serbia with the development of the irrigation strategy. Without further delay, let me briefly provide you with the agenda of today. We're going to have two presentations on climate change and climate change impacts on irrigation and agriculture in Serbia. Our two presenters today, let me remind you that this is the 5th workshop we organize. The two presenters of today are Thalès de Haulleville and Victoire De Wever. They will both present. There will be a series of stops during their presentation. So as the director recommended all of us, please do not feel shy in asking questions. Very short reminder, you can ask questions either raising your hand. You will find the bottom under the reaction icons on the lower tab of your screen, or if you don't feel comfortable in speaking directly, please use the chat. You feel free to write in Serbia or English, no problem. I think we will start now with Thalès' part of the presentation. Thalès, please, the floor is yours.
Okay, hello everyone. Let me just share my screen with you. So good morning, everyone. So let me welcome you again to this climate of irrigation presentation in Serbia. Before we start, I'll introduce you quickly to this presentation. So this presentation will present a quick summary of the material presented in 3 different documents. The first one being the climate change section of the strategy. The second one will be the climate change and environmental brief. And the last one will be the irrigation atlas. So this presentation will be articulated around 4 main questions. The first is, how has Serbia's climate been changing during the last 40 years? The second will be, how is it projected to change over the next 40 years? So that's these 2 first questions will be presented by myself. Then the third question will be, what implication does this have for agriculture? And finally, how do these change shape the current adaptation and mitigation priorities? These 2 last questions will be presented by my colleague, Victoire De Wever. But so how climate has changed in Serbia? Before we go into the details of that, I really wanted to present to you the data source where the data is coming from. So basically, we had 2 types of data. The first will be historical data, and the second will be projected data. For historical data, our main data source was the Republic Hydrometeorological Office of Serbia. It's data coming from 29 weather stations across Serbia. You can see them in the map here. As you can see, they're really well distributed throughout Serbia, so that's a very good point. Unfortunately, it's only point data, meaning that we only have data at one particular point in Serbia, not distributed exactly through the entire country surface. Although it's measured data, so that's very good because it's actually the data that really happened. Another small issue is that it's monthly data. Unfortunately, daily data were not provided. So that means that we could not be able to measure or calculate any data that are calculated on a daily scale. For example, frost days or warm days or the duration of the longest dry spell. These data were impossible to calculate only with monthly data. So for that, we had to look at ERA 5 data. ERA 5 data is GIS data, meaning that it's data that is covering the entire country. And it's created by combining model data with satellites and ground observation. The strong point of ERA 5 is that it's daily data. So from that, we were able to calculate a lot of daily scaled variables. A third database we used was the TerraNet database. It's a database, it's a GIS data as well. So it looks like this, and it's used to estimate actual and potential evapotranspiration. As ERA 5, it combines model data with satellite and ground observation, and the PET, so the potential evapotranspiration, was calculated using Penman-Monteith equation logic. Unfortunately, this database only starts from 2001, so we have roughly 20 years of measurements of PET. Looking at projected data, we used one large database called the NEXT database from the NASA. It's GIS data again, and it's presented as an ensemble of 20 global climate models. So to understand that, a climate model is a way to estimate the future climates. So we will have 20 different ways of estimating the future climates. And on top of that, each model is calculated on the two climatic scenarios, one optimistic and one pessimistic. You can see a climatic scenario as a constraint on these models. So basically, what that means is if we look at the time series of average temperature, for example, and we look at one model constrained in one way, using one climatic scenario, we will have this line. If we look at the 20 models all constrained the same way, in the optimistic way, we'll have these 20 lines. But we can constrain these 20 models as well under a pessimistic scenario, and we'll have these 20 other lines. So basically, we have roughly 40 constrained way of looking at the future. That will be interesting, important a bit further in the presentation. So I just wanted to put that in your head. Now that we know what type of data we have, let's look in detail in the historical trends for temperature. So if we look at the annual trends and the annual time series of temperature, we can look at one weather station. So that's, for example, it's the time series for Belgrade. And we look at the 29 different stations. So we have 29 lines representing the average temperature. If you want to have a general idea for Serbia, we can just take the median value. So the median value is a way of gathering together a bit like the mean, but it's less susceptible to extreme measurements. And we'll have this line. So this line means that 14 station will be higher than this line and 14 station will be below this line. And that's the mean value. This line will be the regression line for this median value. And we can say, okay, we have a trend in average temperature for Serbia. We can do the same for maximum temperature and for minimum temperature. Just one thing you have to keep in mind is that these two maximum and minimum temperatures are actually the maximum and minimum temperature of the year, meaning that it's the highest temperature that happened during any given moment during the year, or the lowest temperature that happened in any given moment during the year. That if one day you have a very high temperature, then the entire year will be very high. If it's and if you have a very low temperature for minimum temperature, then this year will be very low. So that's extremes. If we look in details of this, and we want, for example, look at the maximum temperature, we will see this, but we have a trend for sure, but is this trend is really statistically correct? I'm not going to go in details of statistics here because it's a bit complicated, but I just want to tell you about something called a confidence interval. So confidence interval is that funnel here, and it pretty much says that any line that passes in this funnel will be a decent estimate of the variation of maximum temperature during this period. Meaning that, for example, if you draw this line will be a decent estimate of maximum temperature, as well as the regression line we saw. And this line, unfortunately, is a no variation line, meaning that this will be decent to estimate that there were no variation during this time period. And there's a statistical rule saying that if this line can be fit in the confidence interval, then we have to assume that there were no variation in this during this interval. So unfortunately, this trend has to be assumed as zero, as no variation. If we look at minimum temperature, it will be the same. And if we look at average temperature, as you can see, there's quite a steep slope and a very narrow funnel here, meaning that we cannot put a flat line in this funnel, meaning that this variation is actually solid, is actually statistically acceptable. All of this to say that what we can see is that Serbia is getting warmer. The average temperature increased by 0.57 degree per decade. That's more than 2 degrees since the 80s, which is quite a lot. If we look at the annual extremes, minimum and maximum, as we said, there was no real statistically acceptable trends. So we have to assume that they were somewhat stable. Maximum temperature was around 36.6 degrees, while minimum temperature was around minus 16.3 degrees. That only means, because it's only yearly extremes, that Serbia experienced occasionally extreme cold winter days and occasionally extremely hot summer days. But that's it. That doesn't mean that the winter is getting cooler or that the summer is getting hotter. That is actually shown by the average temperature rising. If we look at the historical change in seasonality for temperature, what we can say, we can look at the average temperature for monthly average temperature. And we can look at it by decades, meaning that, for example, if we look at this line, this is the average temperature of each month in the 80s. So the average temperature in January, the average temperature in February in the 80s. We can look again this at the 90s, and as you can see, it's pretty much the same shape, but slightly higher. If we look at the millennium as well, slightly higher. And if we look at the 2010, again, slightly higher, just always the same shape. If we look at the maximum and minimum temperature, it will have the same pattern, going slowly up, but keeping the same shape. So because the shape doesn't change, we can say that the seasonality of temperature did not change in Serbia. We have more and more hot days and very hot days and fewer frost days and chill hours, that's for sure. But the shape of this seasonality didn't change. For example, if we look at this line, this is the 21-degree line, we can say, okay, that was the temperature that was average in July and August in the 80s. But in the 90s, it was below the average. And in the 2010, it was quite below the average. So a temperature that was average in the 80s actually now is really a cold temperature respectively, if we compare it to it. As a result, the growing season starts earlier, 2 days before, and lasts longer, 3 more days. There's an increase of annual accumulated degree days, obviously. And if we look at potential evapotranspiration, it had increased as well. That's probably due to the fact that potential evapotranspiration is also calculated with temperature as well. There's a lot of variables in this evapotranspiration, but one of these variables linked to evapotranspiration is temperature. So if the temperature rises, evapotranspiration might rise. I don't know if anyone has a question about temperature, about historical temperature till now. No, good.
Colleagues, please do not be shy. If you have questions, feel free really to ask questions. This is the right moment. In all cases, there will be time for questions after the presentation. And if you have questions during the presentation, feel free to use the chat box on the below toolbar. Thank you very much. Go ahead, Thalès.
Okay. So if there's no question, I will move on to historical trends for precipitation. We can really have the same approach for precipitation that we do for temperature. So look at one weather station for precipitation, all the weather station for precipitation, then the median line, 14 station above, 14 station below, and draw a trend here. Before even looking at the trends, what we can directly see is that the precipitation in Serbia are very variable. If we look at the median value here, it can double from one year to the next. For example, in the millennium, in the 2000, the precipitation was less than 400 millimeters, while in 2014 it was almost 1,000 millimeters during 1 year. So that's more than doubling. So it's a lot of variation. We can see there's a precipitation trend that seems to increase, but this is not statistically significant. Again, if we look at this confidence interval, we can totally fit a no variation line in this. So we have to assume that there were no variation in terms of increase or decrease of precipitation during the last 40 years. The average precipitation was around 659 millimeters per year. If we look at precipitation variability, and that's going to be a bit tricky in terms of statistics, we looked at the annual standard deviation at a daily scale, and it stays constant. So for those who are not familiar with statistics, it simply says that the distribution of precipitation throughout the day, throughout the year, was pretty much the same all days, all in every single year. Didn't really change the precipitation variability. If we look at precipitation intensity, so this is the average amount of rain per rainy day, as well, it didn't change during the 40 years. Same thing with the duration of the longest dry spell. If we look at the seasonality of precipitation, we can do the same approach. Look at the seasonality in the 80s, look at the seasonality in the 90s, in the millennium, and in the 2010. And as you can see, it's really not clear. There's really not trends. Sometimes it goes up, sometimes it goes down. So the seasonality of precipitation is also very variable. For example, if we look at February in the 80s, you will see that it went down in the 90s, went up again in the millennium, and went up again in the 2010. But if you look, for example, in September in the 80s, it went up, then it went up again, and then it went down. So there is no clear trends on how the seasonality is changing, simply that the seasonality is also quite variable because the precipitation in Serbia are so variable. So there's no clear trends. Just gonna check if there's any question for historical precipitation. Yes.
Hello everyone. Vladimir Đurđević is here from Institute of Meteorology, Faculty of Physics. Your results are okay, but I just would like to say that you should put some kind of restraint on your results, since that you look into the data from 1980, okay, and the climate change signal starts before that. So in terms of precipitation, I think that this high variability become the common feature of precipitation here during last 30-40 years, and before that the signal was much more stable. Okay. So if you look from the 40s, or if you even look, in case of Belgrade, if you go even further in the past, like 19th century, you will see that this precipitation signal and variability will be much more stable. So it will be good if you can put in your analysis the information that you look into the data just from the 80s. And on the other side, when you look into these long-term trends, you will see that many variables in Serbia have this break point in the beginning of the 80s. So the signal is pretty different starting from the 80s, and if you start for the 40s, let's say, or something like that. So
okay.
I think that it will be good if you can underline that in your analysis.
I totally agree with you. I'll add a comment about the further future past and say that it started to be a variable since then. Thank you for this comment. Any other question?
Yes, Thalès. Sorry, I do have as a moderator, I do have a question in this regard. I think as you said at the beginning, and just to share it again once more with the audience, the amount of data that we could access is limited to what we have shown. And of course, when we had to go by the 80s with all the detailed daily data and so forth and so on, we had to rely on remote sensing data, GIS data. Now, I fully endorse what our colleague just mentioned, and we would be most grateful if the Meteorological Service could share with us this data before the 80s, because it's in our interest to have the largest data set possible. And it would be great if we could have a bilateral meeting on this to have once more our request of data being, answered. So if we could access this data before the 80s, it would be excellent, because it will allow us to fine tune the work of Thalès and colleagues, and to have a more precise perspective of climate change. Over to you, Thalès. Thank you very much.
Thank you. I will just add that I'm totally agree with Jacopo and say that daily data will be great as well, because again, we have to rely on ERA5 whenever you want to look at daily data. But thank you for this comment, Doctor. And I will proceed if you have any, if no one has other comments or questions. So I'll look at the projected trends for temperatures. So if we look at the time series of projected temperatures, we can do almost the same approach than we did for historical data, only not looking at station, but we're looking at models. So if we look at the one model here under the RCP 4.5 scenario, so the optimistic scenario, we have this. If we look at all the models, we have this under the RCP 4.5 scenario. We can take the median line and we can make a trend here. We can do the same under the pessimistic scenario, RCP 8.5. And of course, we can do it for annual maximum and annual minimum temperatures. I am not going to show you the statistical analysis here, but just tell you that all these trends are statistically acceptable. And as you can see, Serbia is expected to continue getting warmer. The average temperature is expected to increase from 0.29 degrees to 0.48 degrees per decade. It's a bit lower than expected that we see by historical data, but it's still, again, a lot. If we look at annual maximum and minimum temperature, they're expected to follow the same general increase. And talking about maximum temperature, it could present a very steep increase, plus 0.82 degrees per decade under the RCP 8.5 pessimistic scenario. It's under the pessimistic scenario, but it's a very, very, very large increase. Although we're talking about maximum yearly temperature, so really the extreme day of the entire year. All of these trends, as I said, were statistically significant. If we look at projected trends for precipitation, I'm not going to go, now you know exactly how we do. So this is the RCP 4.5 and this is the RCP 8.5. We can see that, again, very large variation in precipitation. Within still the same doubling range from 400 to 1,000, depending on the year or the model or the scenario, but still this very, very, very large variation. If we look at the optimistic scenario, it's the precipitation seems to be expected to increase very mildly. But if we look at the confidence interval here, you can see that you can pass this flat line. So this is not significant, unfortunately. If you look at the pessimistic scenario, it seems to expect a mild decrease, and actually this is significant. So this means that under the pessimistic scenario, the decrease of precipitation will be around minus 14.10 millimeters per decade. That is mild considering, meaning that it will be minus 7.8% in the 2060 compared to the level of the 2020 under the pessimistic scenario. But still, it's a decrease. If you look at other variables, the precipitation intensity, the wet days, the duration of the longest dry spell are all expected to stay stable under both scenario. Frost days, ice days, and chill hours are expected to decrease under both scenario, which is quite logical if the temperature is increasing. Summer days, tropical nights are expected to increase under both scenario. Again, logic if the temperature is increasing. And the annual potential of precipitation is projected using the Blandly-Criddle equation to rise under both scenario. This is an estimation using the Blandly-Criddle scenario. It's a very coarse estimation, but it's the only one we can do for projected data. So if I just want to sum up what I just told you until now, Serbia is getting warmer on average and expected to continue to do so. The seasonality of temperature and precipitation did not change, and it's not expected to change. The precipitation in Serbia is very variable and expecting to continue to be as variable. There was no statistically significant change in historical precipitation in Serbia, and only a mild decrease is expected to happen in the near future under the pessimistic scenario. If we look at other variables, precipitation intensity, wet days, and duration of the longest dry spell, they are expected to stay stable. Frost days, ice days, and chill hours are expected to decrease. Frost days between -3 to -6 days per decade, ice days between -0.9 to -1.3 days per decade, and chill hours between -63 to -94 hours per decade. Summer days, tropical nights, and degree days are expected to increase under both scenarios. Summer days plus 5.1 and between 5.1 and 7.4 days per decade. Tropical nights between 2.8 to 6.6 days per decade, and degree days between plus 72 to plus 119 degree days per decade. Finally, the annual potential of evapotranspiration is predicted to increase on both scenario between plus 13 to plus 21 millimeters per decade. So that gives you a general idea about how the climate has changed and is expected to change. Now I will leave the floor to my colleague, Victoire.
Many thanks, Thalès. Before we ask Victoire to start with her part, let's see if the audience have additional questions at this stage, if they want to interact, if they have needs for clarifications. Colleagues, please, the floor is yours. Once again, do not feel shy and remember to use the chat if needed. Over to you, colleagues. All right, Thalès, either you really shocked them or everything was very well absorbed by the audience. Let's keep your question then for the chat or for later on. Please, Victoire.
Okay, thank you very much, Jacopo. So as per the outline for today, now we will be looking at the implications of those climate changes on agriculture, and including some key axes for the water sector as well. So what is for sure is that agriculture has been has been strongly influenced by the weather, and in particular by adverse impacts from droughts to floods, including heat waves, and a decrease of frost days, as Thalès said. The direct impact that we can observe is how climate change is affecting yields. A direct impact is for sure the, let's say, warmer temperatures and the increase of heat waves and decreasing cold days, as Thalès said. There is also one key aspect that is related to the vegetation period and growing season shifts that we have seen. I put also like the graph regarding the vegetation period and the growing season that is directly linked to climate change, with a vegetation period that started 3 days earlier and a growing season that lasts 2 days earlier compared to 10 or 15 years ago. There is linked to that, we also have some changes in the soil moisture balance, with an increasing moisture stress for rain-fed crops, basically. And like the more indirect impacts is related to pests and disease that we have observed in Serbia over the last decades. If we look at how climate change is affecting crop, I put here a very concrete example of one bug insect, Aliomorpha alis, that was found for the very first time in 2015, and that affect crops such as tomatoes, apples, and grapes. Here again, a graph on how the presence of this bug insect is increasing, mainly in, first it was found in the near Brazak and Belgrade, and it is expected to be further spread in southern regions and higher altitude as a result of milder and shorter winter periods. Now, if we look at, thank you very much, Thalès. If we look at climate change vulnerabilities, it is acknowledged in national communications and official documents that agriculture and the hydrology and water resources sector are one of the most vulnerable sectors to climate change. We could identify immediate effect again related to soil moisture changes and increased evapotranspiration, as said, which means higher stress on rain-fed crops, and also higher crop water requirements for irrigated crops. And we have let's say, eventual and less confident effects of climate change that are related to the reduced path of yield growth and yield variabilities, because in the literature you have a link between yield variabilities and drought, for example, and between higher temperatures, and let's say the idea that the yield growth will grow less fast in the future, if we can say it this way. And then you have also the idea of warmer temperatures that could cause direct heat stress in the future, with again some shifts in the length of the growing season and accelerated phenophasis, as for example a faster germination for winter and summer crops, but also earlier sowing for summer crops. What we have seen already in the past is the spread of pest and disease that is expected to be accelerated, as I mentioned already, in other regions and with other types of pest and disease. And then the decreased water availability for rain-fed crops and the higher water requirements for irrigation. So again, the idea of the potential evapotranspiration that we have seen already that has increased over the last 40 years by plus 18 millimeters per decade. And then this, again, potential evapotranspiration that will further increase, as Thalès said, under both scenarios, with the higher increase under the most pessimistic scenarios that could go up by plus 21 millimeters under the RCP 8.5 scenario. And let's say that this potential evapotranspiration increase will have adverse impacts on water requirements for crops. Yes, again, yeah, perfect. Thank you, Thalès. Okay, so here again, the graph. And let's say that in this context of climate change and potential climate change impacts, if you can go to the, thank you very much, to the next slide. So here we wanted a bit like to reemphasize the adaptation and mitigation priorities that Serbia committed to based on the national determined contribution submitted to the UNFCCC. So a mitigation target that aims to reduce GHG emission by 9.8 in 2030 compared to 1990 levels, and with here for the mitigation target, a specific target for agriculture with the reduction of 15% of GHG emission in agriculture by 2030. And here, the adaptation target that aims to shift towards a more climate resilient society. Here in this context, Serbia has developed a series of adaptation measures and key priority areas that include risk reduction, monitoring and research, policies, and capacity building. In this, like in order to be able to respond to those mitigation and adaptation priorities, Serbia developed a solid policy background with national and official commitments and documents to respond and tackle climate change impact. So from the NDC contribution with an updated version still at draft stage for the NDCs, to the third national communication draft, and also a series of sectorial policies that are aligned with climate change impacts and how to respond to them, including the strategy for the agriculture and rural development in the Republic of Serbia, but also the water management strategy for the Republic of Serbia. And here it is also it is worth mentioning the instrument for the EU pre-accession assistance, IPA2, that also includes a climate and environment section that Serbia needs to respond to. Now, if we look at the GHG emissions for Serbia and the mitigation scenario, so we have to say that GHG emissions are mostly coming from the energy and transport sector for around 78% of the total GHG emission, and that agriculture, forestry, and land use is the third largest GHG emitting sector with 7%. In this context, Serbia is expecting to become carbon neutral by 2070. And in order to respond to these big challenges and goal, Serbia developed different mitigation scenario to respond to it, with different levels of expectations and compliance with the EU acquis and the EU 2030 targets, with the reduction of GHG emission that could go up to 80% by 2050, and the lowest, let's say, would be around 33%. In any case, those scenarios exclude the adoption of policies with a potential impact on GHG emission increase, and you also have the adoption and implementation of the EU acquis, as I said, and EU 2030 targets. Next slide, Thalès. If you have a question until now, just let me know and I will be happy to respond to it. Otherwise, I keep going on the barriers and to adaptation and mitigation. So here, based on the literature and the different the review of the different national documents, we have identified legal barriers, institutional barriers, technical barriers, financial needs and barriers, economic barriers, technological barriers, and ecological disequilibrium. To respond to that, there are a series of mitigation and adaptation measures that were identified, and that include the systematic approach to climate change in law and policies for Serbia, the increased institutional organization for climate change, and including the removal of administrative burdens. Also, increased awareness of climate change and the adoption of agro-technical practices for agriculture and water. So that could include also a more efficient irrigation system for the country. Then when it comes to investment, it's leverage investments for the identified measures in adaptation and mitigation. Then the development of sustainable standards and stable pricing for water. The legal framework on GHG emission and monitoring, which is also responding to the EU expectations in this regard, to better quantify and assess GHG emission, even though it was already revisited and enhanced, for the third national communication. And the increase of protected areas and field conservation for biodiversity protection and restoration. Afforestation is also a key aspect for Serbia when it comes to increase forestry removals and the decrease of GHG emissions. In this context, the irrigation strategy have identified key areas, 4 key areas, to respond to those challenges and make sure that we are fully aligned with the existing national framework. And that includes the improvement, the the improvement of the framework for water use in agriculture with enhanced evidence base and the participation of water user organization, for example. Then we have public investments in irrigation and drainage systems. Then public support to on-farm irrigation and drainage, and supporting services. Those key areas are, of course, still under discussion and to be approved in the strategy. Thank you very much.
All right, colleagues, thank you very much to Thalès and Victoire for their very detailed presentations. Colleagues, I see that we have already some question in the chat. Let me start with the first one we have from Mr. Alacevic that asks, thank you very much for the clear presentation. Is there any statistical significant geographical difference between, sorry, no, let me read it. If there is any statistical significant geographical difference evident from the data, north and south? I mean, how does the described changes, Thalès, moves based on the geography and altitude of the country?
Yes, thank you very much for this question. I'll try to, and what I'm going to just do this, go up there and present. I have a map here, so maybe I can show this map. In terms of temperature, we didn't want to work on really a regional level and compare regional I'd say administrative borders. We really worked on general maps, and in terms of general maps, what we gathered is that there's not really a clear difference between north and south, but a clear difference in altitude, meaning that if you are the same altitude in the north and the south, you will have pretty much the same climates. And we had this long conversation with Steve Goss, and we realized that actually most of the agriculture in Serbia is below 500 meters. So we thought about our results and say how this change compared to the data we have. And looking at the Republic Hydrometeorological Office of Serbia, we realized that we only had into these 29 weather stations, only I think 2 stations or 4 stations that were above 500 meters, ski resorts and that kind of thing. So you can see it actually in the historical temperatures. You can see there's like 4 lines here that are a bit lower than the rest, and that's the ski resort. So but because we use a median line and not a mean line, we really are sticking to most of the stations that are below 500 meters. So to answer your question, there is a difference in climate compared to geography, but it's more linked to altitude. And luckily, our data are mainly coming from lower altitude Serbia. So we are confident that our results really fits agriculture in this matter. I don't know if I answer your question correctly.
Many thanks, Thalès. I think it was very clear, and thank you very much. One more question. We have it from Professor Grabic from the Faculty of Agriculture, University of Novi Sad. Professor, if you want to ask the question directly, please feel free. Otherwise, I will read it through the chat. So if you want to take the floor, just please go ahead. Otherwise, I will read it.
Okay. Hello, everybody. I'm from the Faculty of Agriculture from Novi Sad. I'm from the Department of Water Management. And recently, last year, we finished a project, Dry Danube, which was a transnational project and has a lot of outcomes. But one of them was to calculate rainless periods which is very important. And well, at this moment, I cannot tell you for surely the results and trends, but my colleagues can, but unfortunately they are not here. And but I think it's generally a very, very important thing, even for this project. And there is also one portal, Drought Watch EU, where you can actually see the rain forecast, 7 days forecast for each region which was covered by this project. And how it was done? Well, we have in Serbia 20, I don't know the exact number, but all the employees of the extension from each extension service, one employee, maybe 30, let's say, from 30 places in Serbia is being reported weekly to one center. The data are sent. The data on humidity, on the texture of soil, on characteristics of plants, of crops are sent to Czech Republic, to Czech globe, and they produce satellite with a combination of satellite images and other hydrometeorological parameters. They produce this forecast, this for irrigation. So I think it's very, very, very interesting, and it's very valuable results of the project. So and it can be somehow integrated in this strategy for irrigation in Serbia.
Well,
excellent. Yeah, please, Thalès.
Yeah, thank you for this information. That actually seems really interesting for the project indeed. I just didn't clearly understand, because for the forecast, it will not very be important for us as a general project, but if they have historical data on this, that will be very interesting, especially if it's GIS data. But you said it was on a portal called Drought Watch EU.
On the chat there is a link. Yeah.
Okay, good.
So there are also historical data. Yes.
Okay, good, very good. I'll check that. Thank you very much for this information.
Thank you.
Excellent, Thalès. I will share with you the website that I already recorded. Thank you very much, Professor Grabic. I think this is exactly the purpose of this. I mean, this kind of discussion is exactly what we wanted to have, because we, as now well known for those that participated the previous workshops, the main reason, the purposes of these workshops and all the meetings that we have is that we want to have your views. We want to have a shared deliverable that is not just, you know, top down and parachuted on into the strategy, but that reflects also the vision and the data and the results of other colleagues in Serbia. I see we have two more questions. One from Professor Đurđević. Professor, please, the floor is yours.
Hello, everyone, again. I think that you are maybe a little bit too confident about the north and south in Serbia. I think that also my recommendation is that in your analysis, you should say that these results are for the whole territory, or are representative for the whole territory, and that your advice can be that in case that somebody want to go deeper into some analysis, that should go for the local analysis and to make difference between north and south. You mentioned that you use ERA 5 data. I'm not sure that does you use the ERA 5 or ERA 5 land, but if you check the ERA 5 land, and because it is reanalysis, you have, for example, the soil moisture content in the topsoil layer, you will see that there is a difference in terms what is the trend of the topsoil moisture availability on the southern part of the country and the northern one. So I would not be so confident that there is no difference between north and south, even if you look only in the elevation below 500 meters. So it's just recommendation to not be so confident about that.
Excellent, excellent, Professor. We will look at this. I don't know, Thalès, have we looked at ERA 5 land or not?
ERA 5 land in terms of water, soil moisture, I don't think we use ERA 5 land. We used another data source, but we looked into soil moisture. But indeed, I was only talking about climate, not soil moisture. That's, as I'm totally agree with you, Professor, that it's actually a bit more tricky if you look at soil moisture. But in the atlas, there's for every single variable we look into, there is a map of the variables throughout Serbia, and we discussed the geographical distribution. Maybe not in terms of statistics and in terms of it's more a qualitative analysis than a quantitative analysis, but still we discussed the geographic distribution. But I totally agree with you that maybe we should really make a point saying that we are only looking at a general scale for the entire Serbia, and if we wanted to look into a specific region, then this is not exactly the perfect report or atlas for that.
All right, many thanks, Thalès. Well, I would phrase it in a different way. It's not a matter of perfection of the atlas, it's just what we have to look at. Now, in terms of climatic data, we do not simply have the meteo station to run this kind of analysis. And mostly, again, this type of differentiation makes much more sense when you have access to the daily data from local meteo stations. Unfortunately, we were not granted access by the deputed institutions for this data, so we had to rely on remote sensing data. We do have another question from Ana Dokovic. Please, Ana, the floor is yours.
Poštovanje. Javim se ispred Poljoprivredne savjetodavne stručne službe Užice. Moje pitanje je, odnosi se na to da ste rekli da se očekuje smanjenje padavina minus 14,10 mm po dekadi u 2060. godini u poređenju sa 2020. prema pesimističnom scenariju. Šta mislite kako bi to uticalo na Srbiju? Hvala.
Many thanks, Anna. I think it's a very valid question, and I think. Hello, Anna. Can you? Was your question completed?
Da.
Okay. Okay. Thalès, Victoire. Who wants to take this question?
I think I can take it because it's more about the trends. So it's a very valid question. It's actually a very tricky one. So basically, we were discussing about under the pessimistic scenario that the decrease will be around minus 14 millimeters per decade, so minus 7.8% in 2060 compared to 2020. Is that a lot or not? That's a very tricky question, because if you compare it to, if you look at, for example, ecological trends and ecological processes, 8%, almost 10% is quite a lot. If you're looking at natural vegetation that is only rain fed. But if you are looking at irrigation adaptation plans, okay, there will be a slight decrease in precipitation. But if you compare it to the level of variability on a year-to-year basis, we compare 8% to something like more than 100% variation. So I think it's a number that is interesting in terms of dimensioning the infrastructure that we will use to cope with climate change in the near future in irrigation. But if we only look at irrigation, I don't think that 8% will be a big difference in terms of irrigation only. For natural resources, there will be another clearly another subject that is not really the part of this report. But for irrigation, no, I honestly don't think it's going to be a lot if you compare it to the large range of variations on a year-to-year basis. That's my take on it, at least.
Many thanks, Thalès. Let me add that we do have an issue with the potential evapotranspiration. We do. You have to look at also, the combined temperature and precipitation. So the potential evapotranspiration is increasing, and this is quite certain. And that means that we have to look into climate change more deeply and more careful. And it's quite an important topic, because we have to make sure that climate and climate change are well factored in all the strategies and all the new investments that the country will do in agriculture and, of course, related infrastructures such as irrigation, drainage. Let me see if the audience have some particular view, because Anna, you basically anticipated the question I wanted to pose to all the colleagues, and since we are talking mostly about irrigation and drainage, how do colleagues, especially for those that have also conducted studies and work on climate and climate change, how do they see the impact of climate change on irrigation? And I will also ask Steve Goss to provide his views after the audience. Over to you, colleagues. As usual, you can either take the floor or raise your hand. Anna, I see your hand is still raised. Is it an additional point you want to make, or it's from before?
Ne, hvala, sasvim se zadovoljno odgovorom.
Okay, so Steve, why don't, oh no, we have Professor Đurđević, please, Professor.
Okay, me again. So
yeah, please.
I work a little bit on this problem about the water availability in the future and the irrigation. I think let's say the main conclusion from all information that I have, the amount of water will not be a problem in terms of precipitation, because the precipitation will stay, let's say, in little. I mean, it will be different, but in general, the annual amount will be something close to something that we have today. But I think that this annual redistribution will be changed. So in that sense, the management of the water that we have from precipitation will be crucial. How to keep the water that you have during the part of the year when you have a rain, how to keep it for the summer. Because for the summer, if you look now in the observation, you have some kind, it's still not statistically significant, but there is a negative trend in terms of how much rain we have during the warmer part of the year. And also this problem of evapotranspiration is important, because it's not just about that you have less rain during the warmer part of the year, but you have more evaporation from the soil. So that's the reason why I mentioned this water content in the topsoil layer that you have in Area 5 land, because if you look how much water you have in the topsoil layer, you will see that on the southern part, this number is decreasing because of this combined effect of less precipitation during the warmer part of the year and increased evapotranspiration. And on the other side, I know that if you look in the observation, but also in the projections, you can expect increase of precipitation, especially during the colder part of the year and the winter. So I think that the crucial thing is how you can keep that water when you have it in terms of excess amounts, how to keep that water to use it when you don't have that water. So in that sense, I mean that the problem of irrigation in Serbia will be the water management. How you're going to manage this? Also, we can say it, how you're going to manage this high variability that we have in recent years. So I think it's tricky to do it. It's not easy, but I think that the focus should be on that. And of course, I'm not specialist in irrigation, so I don't know how people manage this kind of variability and how you can change, let's say, the annual water cycle to be better in terms of how you're going to irrigate. And of course, there is another thing you also didn't tackle that in your analysis, I think, it's a story about the snow, because snow is also some kind of accumulated rain. Okay, and when you go into the spring, then you have snow melting, so your hydrological cycle minimum in that case is more moved to the end of the summer. And if you don't have snow during the winter, then you don't have this accumulation, so your summer minimum in hydrological cycle, it will be more like in the middle of the summer and not on the end of the summer. And that kind of changes in terms, do you have snow during the winter, and do you have rain during the winter, and we're going to have more rain and less snow in the future, it will change the hydrological cycle, and hydrological cycle is crucial for irrigation. So in that sense also, these dynamics of the snow during the year can be very important. But again, as I said, I think that even if you add this story about the snow, it's again the story about that, how we're gonna keep water when we have it, and then use it when we don't have that water from sky.
Thank you for this remark here. It's actually true. We had an analysis of the snow depth and the snowfall in Serbia in the atlas. I'm just looking at it right now. It was not exactly linked to the precipitation, but we looked into that as well. I'm just looking at it at the moment. Here we go. Let me share my screen again. Here we go. So yeah, we'll look at the current seasonal variation, and maybe I should look. This is the historical time series monthly. But if we want to look at something more clear, so this is the annual time series of the annual accumulated snowfall and snow depth, and both are decreasing as well in Serbia. So that would be probably linked to the issue you showed, that less snow is falling and the accumulated snow in the high altitude of Serbia is actually going down. So if you have less snow depth, then you will have a less, I'd say, storage of water during the melting of this water. Simple as that.
Yes, it's great that you show this figure, because what is interesting and how people should think about this, what I said, if you look into the blue line, you will see that you have extreme, I mean, the highest amount of accumulated snow was in 2012, I say. Mm-hmm. You have 2010, then you have 2011, and you have this peak in 2012 on the blue line. And if you look for the same year in terms of summer precipitation and drought, you will see that the strongest drought ever recorded in Serbia was in 2012. Okay, so we have extreme snow accumulation that year, but the snow was melted so fast that this hydrological cycle was disrupted. And during that summer, we have this extreme drought and extreme losses in agriculture. So in that sense, you can imagine that in the future, if you have less snow, that if you have a repetition of the drought in 2012, that in that case, the drought is going to be much, the agriculture is going to be much stronger affected by that. And also it is interesting that during that year, 2012, when we have this extreme accumulation of the snow, the many people from hydrology and agriculture, because you have this news reporting about this snow, and many people was saying, okay, this is too much snow, we don't want that snow. And people from agriculture and hydrology said, oh, no, this is the white gold, because we need that snow for agriculture production, and we need it for the water resources, etc. And the same year, during the summer, you had this strong drought. So what I would like to say is that you can imagine how the drought can be even stronger if you don't have that snow during the winter. And if you have this high variability, it's something which you can expect in the future. So the 2012 is very interesting year to be analyzed, because we had many extremes, and we had really big impact on agriculture. So one of let's say my recommendation is that maybe when we look into the future, we should think about how many times we can expect that we're going to have a year like 2012 in the future. So is that kind of drought and the situation is going to be one time in 10 years or two times in 10 years, or maybe three times in 10 years? And can we respond by irrigation on this kind of extremes?
Many thanks, Professor. That's an excellent point, and I'm very glad you made it, because it's one of the main chapters of the atlas that Thalès prepared. Because while it's true that the large majority of the water used for irrigation comes from the Danube and the other main rivers of Serbia, snow plays a crucial role in agriculture, and it's absolutely. And besides, let me add that there is not just, I mean, it's besides irrigation, it's also pest control. I mean, there is a number of elements that snow guarantees that without will create a number of issues on agriculture, on the agriculture sector, on the agriculture production. Pardon. Let me give the floor quickly to Steve Goss to briefly give us his views on irrigation, snow cover, and precipitation, and all the data, the climate that we have discussed so far, and irrigation, and with some possible hints on how strategically we should or could address this information. Over to you, Steve. Thank you very much.
Thanks, Jacopo. I think the points that Professor Georgievich made feed very nicely into the economic question that we've been looking at. So, for example, you can build more storage to hold that that water from the spring, early summer, and use it later when you need it. And if you do that, you'll definitely get an economic benefit in many years. But you will also definitely have a cost in building the storage. So we need to look at where the trade-off is. So which of the possible responses will be worth doing and which are not. So we're probing on that, trying to give as much guidance as we can. And one thing we're doing is modeling to try to look at the variability. So we're using the equations underlying crop water and aqua crop to do daily soil moisture balances and impact on crops, looking ahead over 40 years for each of those 20 models in each of the two scenarios. So effectively, we've got 1,600 possible years. So we will get all possible combinations in there, and we want to model that and see, well, how often does it become really important to have irrigation, how often not? We've had to sort of pause that work because we're focusing on drafting the main part of the strategy at the moment, but we'll come back to it, and I think we'll have some very interesting conclusions there. But I think we can draw two already. The first thing to note is that climate change is not just a thing for the future. It's already very much with us. I mean, Serbia's a degree warmer than when I arrived here in 2001. We've seen this change in variability from the earlier part of the mid part of the last century to the last 40 years. So it's very important that when we do the design of irrigation or drainage, we make sure that we catch up with how climate has changed till now. So systems that were maybe designed in the 70s and 80s, they will be based on analysis of climate over the 50s, 60s, 70s. That's not today's climate. We already need to be updating and making sure that we consider the variability and the PET of what we have now. So that, I think, is point one. The second point is that the projected change is actually relatively gradual for the next few decades, and then it will accelerate. And if we do a cash flow analysis for an investment over typically 20 to 30 years, when you discount it, what really affects the net present value is the first 1 or 2 decades. The changes we're expecting to see are not very big compared to what's already happened or where we are now. So I think the most important thing is to make sure we design systems that cope with what we've seen recently and the kind of variability we've got now. And then they'll probably meet most of our needs for the next 20, 30 years. But we will be able to come back, I think, in a couple of months with a much more quantitative response on that. Thanks.
Many thanks, Steve. I think there is a number of elements that could be draw out of this discussion. Now, one element that I would like to stress, and we are stressing it very much at every single workshop and meeting we're having with you colleagues, is the importance of having data, of having this data available, updated, and free for research purposes and all sort of strategic action that the country will take. Again, this will be a very important point also in the strategy, because as you also noted in every single meeting we had so far, it's an important aspect, including training, including you know, to work on the educational side to master this data and to process this data. So let me send again my usual reminder about, you know, the importance of not only generating the data, but also of sharing and making this data available. A data that is not made available doesn't serve the country, it doesn't serve anybody. Do we have any other additional question about irrigation and climate? We have a question from Jovana Raskovic. Jovana, can you please ask your question?
I just mentioned for our site.
Okay. Okay. Sorry, I couldn't. My bad. I don't read the Serbian. I think we now have one additional comment that comes from Mr. Malencic, if I'm spelling correctly his name. Well, there was no intention to exclude Kosovo as a pre-purpose. It's simply that we do not have any data about this region. I also noticed that it was not included in blank. We will add it, I mean, from the geographical perspective, but we do not have any meteo station data, local data available from the region. So we will add it to the chart, to the map, but without data, because I mean in a blank version, because we have zero data about this part of the region. If there is there any other question from the audience related to irrigation strategy or any other topic related to data or agriculture and climate? Please feel free to ask or put it in the chat. Giovanna nicely put again the website of the process. Again, it is not an FAO or EBRD website, is the website where we are as a team with the Water Management Directorate and all the colleagues that are collaborating to this assignment, is the website where we store all the minutes, the recording, the briefs, the presentations, whichever material we have presented to you is available in the website, including the some news, pictures, and other information. Please feel free to send comments, questions at any given moment. One thing to update you on the website is that all the surveys that we have done so far will be updated very soon, uploaded very soon in the website, and they will, some of the survey you can still participate if you feel you have the right information. So feel free to surf this website anytime. If you see problems, please send us a note, a comment, and we will be very happy to address all the possible issues that you are facing. Now, let me thank everybody for we have data and hydrological and meteorological books from Okay, we will be very happy to, Mr. Malencic, to look at this data and to contact you bilaterally to go through this data and add them if necessary, and if these data are compatible with those produced by the other meteorological station. Many thanks for sharing this data. Let me now give the floor to colleagues from EBRD to give us some final words and some final remark, and then to close with the Water Management Directorate. Tankut, the floor is yours, please. Tankut, you're muted. Sorry.
Can you hear me?
Yes,
thank you very much to all participants. I think this was a very useful presentation, and hopefully this will be also a good basis for the discussions and the strategy going forward. And thank you very much.
Many thanks, Tankut. If the Water Management Directorate would like to address the audience with some final remarks, I'll be very happy to give you the floor. All right, so let me, on behalf of the Water Management Directorate, FAO, EBRD, and all the colleagues that have worked for this presentation and to organize this workshop, including our two great translators, Marco and Branislava, that are working behind the curtains, but doing a very hard work to support us all, to Tamara, to Victoire, Jelena, Jovana, Thalès, Milos, Zoran, Steve, all the colleagues. Once again, please surf the website that we shared with you. Thank you again for this fifth workshop we had. I think it was very productive. Thank you very much to colleagues for sharing the websites with additional data we should look at or we should double check. Please be reassured that we will do all the needed checks and rectification where and if needed. And again, thank you very much. And I hope we will be meeting before the end of the year to discuss the first draft of the irrigation strategy. With this, let me again thank you all for your very active participation, for your time, for the information, for the links. And again, goodbye and see you soon, and have a very nice end of the day. Goodbye.
Goodbye.
Thank you. Bye-bye.